Welcome students to this class where we shall discuss about Bernoulli's equation. So before discussing Bernoulli's equation, let us take some assumptions. So what are those assumptions? We shall be taking the liquids, shall be considering some special kind of fluids here. So those are the assumptions. What are the assumptions? The fluids should be, the fluids must be ideal one. Ideal one means this shall be incompressible. Must be incompressible and non-viscous. Number two, the fluids must be irrotational. Irrotational and isotropic. Number three, the flow of fluid must be streamlined. Must be streamlined. So for this kind of fluid, whenever there is a streamlined flow of a fluid which is incompressible, non-viscous, irrotational and isotropic. So for that kind of fluid, the total energy per unit mass of fluid, or the total energy for the total pressure energy plus kinetic energy and the potential energy of a liquid of mass m at a height h will be constant. So I shall be writing that, but to know all the things, let me just list down that all the energies of a particular fluid having suppose mass m. Let me just list down here the density, the fluid that I am going to consider here. The density, let us say the density is rho, mass is equal to m. So definitely the weight of the fluid will be mg. The volume, let us say the volume is capital V. Height from the reference level, suppose from the reference level, let us say that is small h. Pressure is, let us say that is P at a particular point, and as you can see, rho here can be written as, let me just erase it and let me write it down here. Density is rho, which is equal to, which can be written as small m by capital V, mass upon volume. So for that, for this fluid, what is the pressure energy? We have already discussed in the last class that pressure energy for a fluid having this much velocity will be, as you can see here, that is PAX. That is PAX. What is PAX? So suppose here is a liquid column here, and initially here is a cross section. Suppose there is a piston, and if this piston is acted upon by a force P, and if this piston moves by this much distance x, then the pressure energy is equal to PAX. And what is A? A is the area of cross section here. A is the area of cross section. So PAX is this. So as you can see, this AX part is nothing but the volume. Nothing but the volume here. So this is what PV is. So pressure energy is PV, right? And the kinetic energy is what? The kinetic energy KE is equal to half mv square, right? And the potential energy is what? mgh. So according to the Bernoulli's theorem, for a fluid having mass m, volume v, pressure p, the pressure energy, that is PV plus half mv square plus mgh, that is a constant term. So this is one form, this is one form of the Bernoulli's theorem. Now, how will this form change if we consider the Bernoulli's theorem for unit volume? For unit volume, the same equation will look like that if I divide this equation throughout by volume V, that is PV by V plus half mv square divided by V plus mgh divided by V, which is will be giving for another constant, right? So for that, for unit volume, this becomes V. P is equal to, now see this m by V, this part, this m by V, this becomes rho density, right? This m by V becomes rho. So half rho V square plus, now again this m by V comes, this rho gh, that is equal to constant, right? So this is another term, another form of the Bernoulli's equation, right? And now if they try to convert this equation where the mass is taken to be unit. So in case of unit mass, in case of unit mass, this equation will look like what? This PV, I am again dividing this by PV by small m, right? Plus half mv square divided by small m plus mgh divided by small m is equal to constant. Now this part, this v by m, this v by will be, m by v is rho, so this p by v by m will be 1 by rho, so that will become p by rho plus half v square plus gh is equal to constant. So that can be another form of Bernoulli's principle, right? Now let me write another form of Bernoulli's equation, where I shall be considering the unit mass, the unit height from the reference level. So for unit height, this will become P by, let us divide it by h, P by rho g. How to do that? Sorry, not unit height, very sorry. For unit weight, very sorry. For unit weight. So this PV becomes, from this equation, this PV by mg plus half mv square divided by mg plus mgh divided by mg is equal to constant, right? So here see, this v by m is equal to what? Again 1 by rho, so this becomes p by rho g plus this cancel it here, so this becomes v square by twice g plus this mg goes and h is equal to constant. So this is the another part of the Bernoulli's theorem. Now this is sometimes called pressure head. You see, this is having an dimension of height only. This is sometimes called pressure head. Right? So this is an equation you should remember. So this Bernoulli's equation, they do have 4 forms. Now how to prove that? Let us meet in the next video. Till then, bye bye.